Hello students, I am Uday Kumar Kottapalli working as physics faculty at Pearls Academy, Arboganeri. And I have total 9 years of teaching experience in NEET and JEE. I worked in all premium institutes across India. And I completed my graduation from IIT Dhanbad in 2014, after which I started teaching. And I am completely in teaching line since 9 years, and I have a sound knowledge in teaching physics for JEE and NEET students. Hello students, let us discuss about the concept of electric field due to a ring of charge. Electric field due to a ring of charge. Yes, let us consider there is a ring of radius A is having a positively distributed charge on its surface, and there is a point P on its axis at any x distance. Now we are going to calculate the electric field produced by this ring at any point P which is at x distance from its center, and the radius of the ring is A. And this derivation we can do by using the concept of point charge electric field. As we know, electric field due to any point charge at any x distance is given by K into Q by the distance square, where I'll just imagine a point charge on its surface somewhere here, which is like dq, where total charge let us take as Q, and point charge on its topmost edge let us consider as dq. And due to this dq at this point P, electric field will be like this. Let us say it as dE, and the value of dE is K into dq by the distance square as like this, where it is x and it is a, so it will be a square plus r square x square under root, and this value will be a square plus x square under root whole square. So electric field due to that point charge on the ring is K into dq by a square plus x square. And if I consider one more d exactly at the opposite point of the ring, like diametrically opposite point of the ring, then that electric field will be in this direction with the same magnitude. Magnitude of this d also will be same as this. If I take this angle as alpha, of course this angle also will be alpha, or if I take this angle as alpha, this also will be alpha, and similarly we can write this as alpha, and also this also will be alpha, because both the upper part and the lower part of the section will make the equal angles because the same distance of the point P as well as the radius. So both are similar, like so angles will be same. So if I take the components of this dE now, here it will be dE cos alpha, here it will be dE sin alpha, and for the bottom one here it will be dE cos alpha, this will be dE sin alpha. As we discussed, dE magnitude is same and the direction of the component of dE is equal and opposite, so it will get cancelled. Now I can say the effective electric field at point P due to this pair of charges, this pair of dq will be dE cos alpha plus dE cos alpha. Like it is the sum of the cos components of electric field of that particular pair of charges. Like this we can have infinite number of pair of charges. So each pair contributes dE cos alpha at point P towards right according to the diagram. So the net value of electric field on overall ring, total pairs of the ring will be, the effective value will be dE cos alpha. So effective electric field will be integral of dE cos alpha. That means if I take all the pairs possibly on the ring to contribute the electric field at point P, that will be the summation of the cos components of electric field due to each pair. Summation of the cos components, that is what integral of dE cos alpha. So we can write E effective is equals to integral of dE value k dq by x square or a square plus x square into cos alpha. So if I take the constants out, k by a square plus x square cos alpha. From the diagram we can write cos alpha as x divided by root over a square plus x square into integral of dq, where integral of dq will be q. It will be like kqx by a square plus x square whole power 3 by 2 towards right. This is the electric field magnitude as well as direction. Since it is positively charged ring, electric field is towards right. If it is negatively charged ring, exactly cos components will be acting towards the center of the ring, because the electric field at point P, if it is negatively charged, will be directed towards the dq, towards the point position vector of the dq. So in that case, this dE cos alpha and this dE cos alpha are total dE cos alpha components will be acting towards the center. So the direction of electric field either towards the center or away from the center of this circular ring will be decided by the charge on it. And the magnitude value of the electric field is kqx by a square plus x square whole power 3 by 2, where a is the radius of the ring and x is the point P's distance. And also we can conclude one more point, that if x is 0, which means the point P is at the center of the ring, the electric field will be 0. So we can say like electric field due to a charged ring at its center will be always equals to 0 if it is uniformly distributed. And if you go away from the center at any x distance, electric field will be given by kqx by a square plus x square whole power 3 by 2. Okay, we calculated electric field due to a ring of charge. It was E is equals to kqx by a square plus x square whole power 3 by 2. Okay, if it is positively charged ring, it will be away from the center of the ring. If it is negatively charged ring, it will be towards the center of the ring. Now we are going to check the maximum and minimum value of this electric field. So for that, as we know, for any function f of x, y is equals to f of x is there. To find out the maximum or minimum, the basic rule that we follow is, we'll differentiate it and equate to 0. அப்படின்னா எலக்ட்ரிக் ஃபீல்டு எக்ஸோட வேரி ஆகுதுனால அதை டிஃப்ரென்ஷியேட் பண்ணிட்டு ஈக்குவல் டு 0 பண்ணணும். அப்படி பார்த்தா டிஇ பை டிஎக்ஸ், இது வந்து u by v ஃபார்மேட்ல இருக்கு. So we know that if it is in u by v format, u into v into differentiation of u minus v into differentiation of v divided by v square. So if we do that, it will be like a square plus x square whole power 3 by 2 into differentiation of this part, which is kq, x differentiation is 1, minus kq x differentiation of this part, which is v, will be 3 by 2 into a square plus x square whole power 3 by 2 minus 1 into 0 plus 2x divided by v square. A square plus x square whole power 3 by 2 whole square is equals to 0. Anyway, if it is coming, denominator part is coming this side, will be multiplied by 0. So that will be 0. So finally we can write a square plus x square whole power 3 by 2 into kq is equals to kq into x into here 2x into 3 by 2 into a square plus x square whole power 3 by 2 minus 1, which is 1 by 2. So we can cancel that, this part and here this part. Here 3 by 2 is their power, so 1 by 2 went, it will be like one part left. So a square plus x square into where kq will get cancelled is equals to 2x square into 3 by 2, where this 2 also will get cancelled. So we can write a square plus x square is equals to 3x square, from which we can write a square is equals to 3x square minus x square, which is 2x square is equals to a square. Then x value will be a by root 2, actually plus or minus, because it is having the both directions, like electric field can be possibly towards left as well as towards right. So in such case, if we take it is maximum at plus a by root 2 and minimum at minus a by root 2. So overall, if I plot a graph, let's see graph here, if I plot a graph of electric field versus distance of the point P, which looks like this, electric field versus distance. So it will be like increasing and reaching its maximum value, and then decreases, and at infinity it becomes 0. So this side also it will be like this. So this is E max, where this point is a by root 2, and this is E minimum. So this point is minus a by root 2. So the final conclusion is electric field due to a ring of charge is kqx by a square plus x square whole power 3 by 2, in which its maximum and minimum value is given at x is equals to plus or minus a by root 2, and the graph of electric field versus distance of point P will be varying like this, which means it increases and reaches its maximum value and then decreases and becomes 0 at infinity, both the sides of the ring. Now let us see the concept of torque experienced by a dipole placed in any external uniform electric field. So let's take a uniform electric field E, and now let us see the concept of torque experienced by a dipole placed in any external uniform electric field. So let's take a uniform electric field E, and a dipole of dipole moment, P, arranged like this. Uniform electric field E, and a dipole is placed in this uniform electric field, minus q here and plus q here, whose dipole moment will be in this direction, P. Dipole moment will be always from negative charge to positive charge direction, and the angle between the electric field and the dipole moment is theta. Now, the force experienced by this positive charge due to the external electric field is QE towards right, and this negative charge is QE towards left. If it is fixed at its center, then it will be having tendency to rotate like this. Because it is fixed here, when we apply some force at this point, this force will try to rotate it in clockwise direction, and this force also will try to rotate it in clockwise direction. So we can write torque on plus q charge is the force into perpendicular distance. And on minus q charge also force into perpendicular distance. And we know this distance from the center of the dipole to charge, let's take as L, and this also will be L. Now perpendicular distance in rotational mechanics always stands for the distance between the line of action of force and the axis of rotation. For example, this is the axis of rotation and line of action of force is acting like this. So this will be the perpendicular distance. I mean line of action of force को axis of rotation के shortest distance एधर को आधा perpendicular distance. This is theta and this length is L. So this component will be L sin theta. L sin theta. அப்படியே இந்த டிஸ்டன்ஸும் perpendicular distance ஆயிடும், அதான் L sin theta. அப்போ torque on positive charge will be force into perpendicular distance L sin theta. Clockwise along with the direction I am writing. And torque experienced by negative charge is also F into L sin theta. This is also in clockwise direction. So net torque will be 2F L sin theta in clockwise direction. So now if we take net torque, final expression of the net torque, as we know 2F is QE, force experienced by the positive charge as well as negative charge in external electric field is QE. So it will be QEL sin theta into 2, and we can write 2QL. I mean the product of the charge and the distance between the two charges, like Q into distance which is 2L, is known as dipole moment P into E into sin theta. So the final expression of net torque is PE sin theta. And P is a vector quantity, E also a vector quantity, and it is combined with the sin theta, and we know the torque is vector quantity. So we can write torque vector is equals to P vector cross E vector. It can be given by the cross product of the P vector and E vector. So finally, when any dipole moment is placed in any external electric field, it experiences a torque of amount PE sin theta, and vectorically it is given by P bar cross E bar. And based on this concept exactly, recently in 2023 NEET, they asked a very simple question. If you understand the points clearly, whatever that we discussed, easily you can solve the question. Let us discuss the question after this. Let's discuss the question from the concept of electric dipole, which was asked in 2023 NEET. And the question is, an electric dipole is placed at an angle of 30 degrees with an electric field intensity 2 into 10 power 5 Newton per coulombs. It experiences a torque of 4 Newton meter. And then calculate the magnitude of the charge on the dipole if the dipole length is 2 centimeters. Dipole length is 2 centimeters. Yeah, as we discussed, the torque experienced by dipole is tau is equals to PE sin theta. If you see the values, torque is given 4 Newton meter SI system only, and dipole moment is P, and electric field intensity given is 2 into 10 power 5 Newton coulombs, and the angle between electric field and dipole moment is 30 degrees. Sin 30 we can write. Okay, then it will be 4 is equals to P. P is the dipole moment, which is the product of Q and L. So if we take it into sin 30 1 by 2, 2 into 10 power 5 into sin 30 is 1 by 2. So and length also given as length of the dipole is 2 centimeters, 2 into 10 power minus 2. So this 2 will get cancelled, and this 2 times, and here 10 power minus 2 and 10 power 5. So 2 is equals to 2 is equals to q into 10 power minus 2 into 10 power 5. So q will be coming out to be 2 into 10 power plus 3. If it is coming this side, it will be 10 power minus 3, which is 2 millicoulombs. The right answer is 2 millicoulombs. Yeah, let's discuss about the concept of average and instantaneous velocity in kinematics. Average velocity is given by the total displacement covered by the body in the total given interval of time. And instantaneous velocity is given by the velocity of the body at a particular instant of time. So in mathematical point of view, if we say it, if the limit of time tending to zero, like the limit of time interval is becoming very, very small, at that time whatever the displacement covered by the body is known as instantaneous velocity. Now we can say that instantaneous velocity as if the limit of delta t is tending to zero, then average velocity becomes ds by dt, which is actually known as instantaneous velocity. So the expression for the instantaneous velocity is ds by dt. This instantaneous velocity mathematically we can say as the rate of change of s with respect to time, which is differentiation of s with respect to time. So which is related to the concept of slope. Like if I want to calculate instantaneous velocity in case of displacement time graph, I should always go with the differentiation of s with respect to time, which is nothing but the slope of the graph of s versus t. As we know, slope of the graph s versus t, or slope of any general graph in xy coordinate system, we can write as let's take x1 and x2. Corresponding to that x1, the value of y coordinate is y1, the value of another y coordinate of x2 is y2. Then if I take this as a single small straight line, this becomes delta y, this becomes delta x. Then we can write delta y, delta x. If it is theta, it forms a right angle triangle, so in which we can write tan theta is equals to delta y by delta x, which is nothing but slope of that particular part of the curve. If this delta y is tending to very small value and delta x is also tending very small value, this tan theta can also be given as dy by dx. By applying the exact point in this instantaneous velocity, if I plot a graph of s versus t, if I replace that y and x as s and t, then this tan theta will be equals to ds by dt, which is nothing but instantaneous velocity. So we can say that instantaneous velocity of a body can also be calculated by the graphical method with the slope of s versus t graph. Like the slope of s versus t graph always equals to instantaneous velocity at that particular point of the tangent. Like if we take a situation like s versus t graph is plotted something like this. If I pick any point here P, if I pick any point here Q, if I want to say the nature of the instantaneous velocity at the point P and point Q, I can say like I will draw a tangent to that particular point P, and with the reference line I will take the tangent angle theta. So this theta is less than 90 degrees. So slope at this point is nothing but tan theta because it is S versus T graph. If it is tan theta less than 90 degrees, tan theta is always positive. That means at this particular point, velocity of the particle is positive, And at this point Q, if I want to check the velocity nature, same tangent if I take, and this angle will be the angle of tangent, which is more than 90, and we know more than 90 tan theta value will be negative. For that case, velocity of the particle at Q will be a negative value. So we can classify the nature of velocity, maybe increasing or decreasing or positive, negative, constant, whatever it is, by using the concept of slope in case of instantaneous velocities. Like the conclusion is tan theta or the tangent angle drawn to the point in a graph is always the slope of that graph at that point. If it is S versus T graph, that is nothing but instantaneous velocity. So slope of the graph is instantaneous velocity in case of S versus T graph. If I replace this S versus T graph into velocity versus time graph, then tan theta will be dV by dt, which will be instantaneous acceleration. Related to that, there was a question in 2021 paper, NEET paper. Let us discuss about that after this. Yeah. Just now we discussed about the concept of slope and instantaneous velocity. Related to that, there is a question which was asked in previous NEET exam 2021. So the question is, the displacement time graph of two moving particles makes angle of 30 and 45 degrees with x-axis as shown in the figure. The ratio of their respective velocity is very simple. We just discussed that slope is nothing but tan theta is nothing but dy by dx. If it is S versus T graph, this is nothing but ds by dt. So what we are calculating, it is nothing but instantaneous velocity only. So simply we can write velocity of the first particle to the velocity of the second particle ratio, if I take according to the graph, that is nothing but slope of the first curve to the slope of the second graph ratio only. What is the slope here? First graph, if I take tan 45 divided by this angle tan 30, second one tan 30, then tan 45 is 1 is to tan 30, you can take like sin 30, 1 by 2 divided by cos 32 by root 3. From this we can write 1 by root 3, which will be root 3. So the correct answer is 1 is to root 3. So the slope, when the slope is given or the graphical expression is given for instantaneous velocity or instantaneous acceleration, remember always slope of that graph is equals to tan theta is nothing but the instantaneous velocity if it is S versus T, instantaneous acceleration if it is V versus T. Thank you. Yeah, now it's time to discuss about the strategy of NEET paper. If you see the previous papers of medical exams like AAPMT and JIPMER in 2013-14 time, the physics part was a little different in the sense like complex questions were there, but after 2015 and 2016 completely NEET strategy changed only because of making the students to prepare towards the NEET exam. If you see 21, 22, 23 papers of NEET, particularly physics part, very simple questions were asked, like almost NCERT level. But the only thing is, the student have to have the idea what to prepare and what to not prepare. Like what are covered in the syllabus, which type of questions they asked previously, and which type of approach of the solving questions is required. If you can focus on these particular things, definitely you can crack the NEET exam easily with very good percentile in physics, chemistry and also biology. Many students will have the complexity in physics only because of not understanding. The thing that not understanding, if you underline, that is not actually not understanding, it is not showing the interest. When you are showing the interest towards physics, to understand the physics, to listen the physics class, to explore the physics problems, to solve the physics questions, definitely physics becomes very simple. I promise you it will be even easier than biology. But the thing is, you have to choose a right institute with a right teacher, where the individual focus on each and every student is there. Like our academy, we produced very good result in very short period of time. Like last year we produced nearly some 15 medical seats out of very few students, like approximately some 50 students written the exam, out of which we have got the result of 15 medical seats. So like this type of institutes where the teachers and student interaction happens very clearly and very nicely, you can understand the concepts and you can really get good marks in physics and other subjects also. And the strategy of preparation must be like well defined. Like when you are preparing for something, you must have a plan about it, like what to prepare and what to not to prepare, as I told you, and that can be done only with the experienced staff. When you choose an institute with experienced teachers, like our academy, where the teachers are having very good experience and sound knowledge in respective subjects, where they worked in very bigger institutes, are doing good here. So you can think of it and definitely you can join with us, and we are going to start crash course by March 23rd. Thank you.